Hello everyone! Now, we're going to look at a question about radical numbers. They're asking what the result of the operation is. Okay, so dear friends, when a question about radical numbers is asked, SIM definitely asks these numbers in relation to each other, alright? For example, I'm going to start by simplifying square root of 63 and square root of 28. Notice that the square root of 63 is the product of 9 and 7, right? Look, the 7s are common. And the square root of 28, friends, is the product of 4 and 7. Do you see the connection? Very nice. Now, from here on, we can tidy things up. Look, this part is 1 over square root of 7 plus, friends, inside the root, right? Since 9 is a perfect square, it comes out of the root. So it comes out as 3, making it 3 root 7 here. And in the denominator, we have our 7. Divided by, if we tidy this up, 4 comes out of the root as 2. So we've rewritten it as 2 root 7. Now, what are you going to do here? You'll make denominators equal. I'll use a quick method. Let's do it. It's like we're doing cross multiplication, okay? Let's multiply 1 by 7. I'll continue from here. I multiplied 1 by 7. That's 7. Plus I'm multiplying root 7 by 3. Actually, let's do it like this. Even 3 times root 7, and then I multiply that by root 7. Guys, what happens to these root 7s here? One of them will turn into a 7. I mean, 7 times 7 is 49, right? If it's 49 inside the root, you can take it out as 7, can't you? So, these expressions will directly eliminate the root. We'll end up with 7 as the result here. Let's keep going and see. Divided by 7 times root 7, friends, and I also multiplied these two, so let's write it as 7 root 7. Divided by 2 root 7. So, what do we get from here? Here, we have 7, and 3 times 7, guys, is 21. If I add them up, this part will be 28. 28 divided by 7 root 7, divided by, look, this is the long fraction bar. Pay attention, because this is our first fraction. 2 root 7. So, what are you going to do? You'll write the first fraction as it is, and flip the second fraction and multiply. So, 28 divided by actually, should we do it like this? Simplification. Let me do it now. Let me organize it like this first. Here, guys, this was the first fraction, and this was the second fraction. There's a 1 in the denominator, right? It becomes 1 over 2 root 7. Nice. Now I can simplify. When we simplify 28 and 7, we get 4. Let's multiply 4 by 1, so it becomes 4. There's a 2 here. Pay attention. What happens when you multiply 2 square roots of 7 together? You get 1 7, right? If I simplify, let's divide 4 by 2. Friends, we'll get 2 from here. From here, 1, so our result will be 2 over 7. Hi guys! Now, we have another type of question in a different format about radical numbers. Now we'll see that. In this question, they're asking what the result of the operation is. Okay, now dear friends, the denominator can never be a radical expression. So what are you going to do? You have to get rid of the radical. How? By multiplying by the conjugate of root 5 minus root 3. What is the conjugate, friends? Root 5 plus root 3. Did you notice? The only difference is the signs here. Alright, let's sum it up. If you multiply these two expressions, root 5 plus root 3, I closed it, times root 5 plus root 3. Friends, what caught your attention here? Isn't it a perfect square sum? So, this expression here is the square of root 5 plus root 3. There, now it looks good, right? This is a difference of squares. Let's solve it like this, guys. If you multiply 2 root 5s, you get 1 5, okay? You know, 5 times 5 is 25, so inside the root it's 25. That means when you take it out of the root, it becomes 5, right? Nice. If you multiply root 3 by root 3, friends, you'll get 3. I multiplied the plus by the minus. Minus. Let's also write this as minus root 15. From here, you'll get 2. Now, this was a perfect square sum, right? How did you expand it? The square of the first term, the square of root 5, friends, is 5. I multiply the first term and the second term. Root 5 times root 3 is root 15. I take twice that. 2 root 15. Since it's positive, I write it as plus, plus. Then I take the square of the second term. So, we take the square of root 3. That makes 3. Good. Divided by, and there was a 2 below, minus root 15. Let's write it like this. I added 5 and 3.
8.
8 plus 2 root 15 over, guys. I'm going to simplify the denominator here again, okay? Think of there being a hidden one underneath this. Imagine we're multiplying by 2. If you multiply 2 by root 15, you get minus 2 root 15. Now it's divided by 2, friends. Look, plus root 15 and minus root 15 cancel each other out. So what's left here?
8.
And we had a 2 in the denominator. So 8 divided by 2 gives us 4 as the result. Hello everyone, A and B are real numbers. In this case, they're asking what the product of A and B is. Okay, now dear guys, in these kinds of questions, we try to get rid of the roots, all right? How are we going to do that? Look, they've given us a cube root. So what do we do right away? We take the cube of both sides of the equation. When we look at the expression below, they've given us a fourth root, so we immediately raise it to the power of 4. Great. Now, pay attention. These exponents will eliminate the roots, okay? We're left with 3 to the power of a here, friends. And let's even write the 4 like this, shall we? Isn't it the second power of 2? Since it's 2 squared, you multiply the exponents. So 2 times 3 makes 6. All right, so what did we do here? The 4's have eliminated the root. So 4 to the power of b equals 3 to the power of 4, friends. Okay, now let's tidy this part up again. 3 to the power of equals 2 to the power of 6. Guys, let's also write this part as 2 to the second power. 2 to the power of 2b equals 3 to the power of 4. Now, look, 3 to the power of a can never be equal to 2 to the power of 6, friends. Let's do it like this. Let's switch this expression around. You'll see now that nothing different will happen. 2 to the power of 6. If you swap these, 3 to the power of 4 equals 2 to the power of 2b. Now, do you see that the bases are equal here? Good. So, in that case, I can compare the exponents here, okay? So, over 4 equals 6 over 2b. Friends, if I cross-multiply like this, a times b times 2 equals 6 times 4, which is 24. I can simplify the 2 in 24. The value of a times b will be 12. They already asked for a times b, so our answer is 12. Hi everyone. Given that x and y are positive integers, we are given 2 equations. They are asking us for the sum of x and y. Okay, guys, this is a ratio and proportion question. So, what do we do right away? Look, this means that the value of x will be 3 or a multiple of 3. And the value of y will be 5 or a multiple of 5. So, what are we going to do now? We're going to substitute these x and y values into the places we see under the square root. Now, wherever we see 3 times x, we write 3k. I put it under the square root and closed it. I open another square root and we say 5 times 5k. We wrote 5k wherever we saw y. It equals 16. Now, when we multiply 3 by 3, friends, we get 9k, and 5 times 5 gives us 25k. It equals 16, guys. 9 will come out of the square root as 3, and k will remain under the root. So, 3 times square root of k, let's also take out the 25, which will come out as 5. We got 5 times the square root of k. Equals 16. Now, pay attention. The indices of the roots are the same, and what's inside the roots is the same. So, we can easily add or subtract here, right? Let's add them up and see. I added 3 and 5. 8 times the square root of k equals 16. Let's simplify this part nicely right away. Friends, the value of square root of k is equal to 2, right? So what are we going to do? Look, the root. You need to get k out from under the root. You'll immediately square both sides of the equation. So, what should we do right away? See, the square root here is gone, right? K comes out like this. I multiplied 2 by 2. 4. Super! They asked me for the sum of x and y, right?
Yes.
Friends, x plus y equals 8 times k when I add them up. And I found k to be 4. So, 8 times 4 means our answer will be 32.